In this video, we're going to do the final review, and I'm just going to do problems 1 to 5. Okay, so the first one says express each angle in radians. So you have to remember that what you're going to do is use your multiplier, which is pi over 180. Okay, this is like doing dimensional analysis, and this whole fraction just equals 1, so we can use it for conversion purposes. Okay, after I reduce, and I'll let you do that, I get 13 pi over 36. Okay, next one. Multiply it again by pi over 180, and we're going to do some reducing, and after I reduce, I get negative 2 pi over 3. Make sure not to lose your negative. It's easy to do that. So keep track of the negative and check your answer as you go. Okay, next ones. This says express each angle, this time in degrees. You're going to use the same multiplier, but you're going to use its reciprocal. So turn it upside down. The pi's will cancel, and after I reduce, I get 15 degrees. Negative 5 pi. Again, you're going to use 180 degrees, because degrees is our desired unit. That's why it's on top. And we end up getting negative, don't lose the negative, 900 degrees. Okay, so on the video, I can't split screen. So I'm going to go back and forth between my screen and the formula sheet, because this says find the exact value of the sine, cosine, etc. So that means I need my unit circle. So let me just pull that up, and I'm going to put the unit circle up, and I'm going to say, okay, let's do it this way. So for A, what I want is the sine of 5 pi over 4. So this is what I want you to do. Find where 5 pi is. That's there. Because all students take calculus, I know in this third quadrant, right? So this is first, second, third, and fourth. I know in this third quadrant, sine is going to be negative. Write down your negative first. Then match up the denominator to find your reference angle, and use the sine, because sine is the second pair, and you're going to get negative root 2 over 2. So other things to remember. Your coordinates that you see outside are in the order x, y. And they're also in the order cosine theta, sine theta. Okay, you want to definitely be aware of that. Okay, so your A answer should be negative root 2 over 2. Okay, all right, now let's go to B. So I'm going to write B over here so I can still, actually what I'm going to do is I'm going to erase this really quick, and we'll do B over here so I can still use my unit circle. Okay, so for B, they are looking for the cosine of 4 pi over 3. So again, what I'm going to do is I'm going to figure out where that is on the unit circle, and it is, change color so it looks like it was different, it is 4 pi over 3 right there. In this third quadrant, only tan is positive, therefore I'm going to make a negative. Then I'm going to say, okay, match up the denominator to find your reference number. Cosine is the first one, so I have negative 1/2 for an answer. Okay? All right, let's erase what we have here, and we're going to do the next one. So the next one is tan. So I have tan of negative 2 pi over 3. So I am on 3C. So the tan of that. Okay, so first off, this is not on the unit circle. So you could do a couple of things. You could say, all right, positive 2 pi over 3 is there. Therefore, negative 2 pi over 3 should be here. Okay, if that's not comfortable, take your angle, negative 2 pi over 3, and you're going to have to add a full circle, which is 2 pi. But because we have thirds, we can't add 2 pi. we're going to instead add 6 pi over 3. And when we do that, we get 4 pi over 3, which is exactly where I said it was going to be. Okay, so in any event, whether you think negative or you use coterminal angles, your angle will still be 4 pi over 3. So now what the coterminal angle of 4 pi over 3 I can use to find the value, the tan value for negative 2 pi over 3. Okay, so 4 pi over 3 is in that third quadrant. In that third quadrant, tan is positive. Match up your denominators up here for your reference number. Remembering that tan is sine over cosine, or radical 3 over 2 divided by 1/2. And remembering also that we never really divide fractions, we really multiply by their inverse. My answer should be positive root 3. Always include your sign so that you know you have verified the sign. Okay, so that takes us down to 3D. Let me just get this cleaned up so we can use the same unit circle once again. And you want to really be very familiar with using your unit circle. Okay, so 3D. Here is 3D. It's asking for the cotan of negative pi over 2. Okay, so positive pi over 2 is right here. Negative pi over 2 will be going the opposite direction, and it's going to be right here. Now, you can use this angle because that's where the negative pi over 2 would be, or if you would prefer to be more confident and use your coterminal angles, you're going to add 2 pi, but since we're in halves, we can't add 2 pi. We're going to instead add 4 pi over 2, which gets us to 3 pi over 2, which is exactly where I said we would be. Okay, cotan is cosine over sine. So let's look at this. This is a quadrantal angle. The first value is cosine, so that's going to be 0 over negative 1. Okay, that equals 0, and we're done. Now, on previous assessments, this has been a bit of an issue. 0 over 1 is 0, but 1 over 0 or negative 1 over 0 is undefined. Recognize the difference between those two concepts. Okay? All right, let me get rid of this. And again, the answer for 3D was 0. Okay, so now we're going to go into 3E. And 3E, the problem says cosecant of 7 pi over 3. Okay, so cosecant is the reciprocal of sine. Don't flip the angle over. That would just be silly. So look, is this angle 7 pi over 3 on my unit circle? And it's not, because 5 pi over 3 would be here. Okay, now I'm going to get back on the unit circle by subtracting a full circle. Okay, so let's think about that for a second. If I took 7 pi over 3 and I subtracted a full circle, which would be 2 pi, I would first have to put this into sixths, so I'm going into thirds, excuse me, so I'm going to make it 6 pi over 3. If I subtracted 6 pi over 3, I would get to pi over 3. Okay, now, I could have done that by just continuing around the circle in a positive way. So if this is 5 pi over 6, this would have been 6 pi over 6. And then this would have been 7 pi, over 3. This would have been, so this would have been 7 pi over 3 right here. And that's where I got to by using my coterminal angle concept. So in any event, I really now want the cosine of pi over 3. So cosecant of pi over 3. That's going to be 1 over the sine of pi over 3. Well, what is the sine of pi over 3? The sine of pi over 3 is root 3 over 2. So 1 over root 3 over 2 is going to be 2 over root 3. Now, I can't give that as my final answer because I can't have a radical in the denominator, so I'm going to rationalize that. And 2 root 3 over 3 is my final answer for 3e. So the cosecant of 7 pi over 3 is 2 root 3 over 3. And we have one more of these to do. So let's do the next one. I'll erase all this again so I can continue using this unit circle. So make sure you make the unit circle your friend. Okay, so the last problem, so this is 3f in this little section, is the secant of negative 3 pi over 4. Okay, so positive 3 pi over 4 stops here. So negative 3 pi over 4 must stop there. If that's comfortable, go ahead and use that. If that's not comfortable, take your negative 3 pi over 4 and add a full circle, which is 2 pi, or 8 pi over 4, and we get 5 pi over 4, which is exactly where I put us by going and thinking negatively. Okay, so I now know that I can see in this quadrant, since I know secant is the reciprocal of cosine, and in that third quadrant, cosine is negative. So first write down a negative. Then look up and find your reference number, which is pi over 4, and therefore cosine is going to be root 2 over 2. So 1 over root 2 over 2 equals a negative 2 over root 2. Okay, so let me think about this for a second. Okay, so that's good. Now we can't leave a radical in the denominator, so rationalizing it gets me negative 2 root 2 over 2. So the 2's can cancel, and I'm left with a negative root 2. So that answer for 3f is negative root 2. Okay? Okay, so now we can go back into, so let me see if I can just pull this up. Yeah, back into this. I've answered these questions for us. I'm not going to fill them in because I did it on the screen, and you have the answer key as well. So let's go down to question 4a. Find a positive and negative coterminal angle for the following. So the first one's in degrees. So what I want to do is I want to take my 20, and to get another positive coterminal angle, I'm going to add 360 to it. That gives me 380. That's my positive coterminal. Take your 20 and subtract 360 from it, and that gives me negative 340, and that's my negative coterminal angle. Okay, next thing, I'm going to deal in radians. So in radians, I'm going to take my radian measurement, and I'm going to add a full circle. Now, a full circle is 2 pi, but I'm going to add it as 12 pi over 6 so that I can handle the sixths. Negative pi plus a 12 pi over 6 is a positive 11 pi over 6. There's my positive coterminal angle. And so to get the second angle, subtract, and when I subtract, I go more negative, and so therefore it's going to be negative 13 pi over 6. Those are my two angles. Okay, for C, take your 2 pi over 3 and add a full circle, but add it in thirds, so I'm going to add it as 6 pi over 3. That gives me 8 pi over 3 for my first coterminal angle. That's the positive one. Then change this to a subtraction. And when you change it to a subtraction, 2 minus 6 will give you a negative 4 pi over 3. And that's your second angle. Okay, so the next problem, which is the last one we're going to do for this video, is number 5, and I'm going to need to have a formula sheet. So let me go back into the formula sheet so you can see which formula we're going to use. Okay, so I'm going to get all this erased so we don't have this to worry about for right now. And come back over here, and I'm seeing that I'm going to need to have these formulas right here. So let's look at the problem. The problem says that my sector of a circle has an arc length of 2 centimeters. That means S is 2 centimeters. And the central angle, which is the angle symbol, okay, that's your theta, is 0.4 radians. Now remember, these formulas are highlighted in yellow must use theta in radians. So if it's not in radians, you've got to convert it first. In this situation, I was in radians. So they say find the radius of the circle and the area of the circle. Okay, I'm going to use this first formula because I have the sector length and I have the theta, so I can easily solve for the radius. So to do the first part of the problem, I'm going to say S equals R times theta, and my S is 2, my theta is 0.4, and R is what I'm solving for. So if you take the 0.4 and put it under your 2, so 2 divided by 0.4, grab your little calculator if you like, 2 divided by 0.4 gives me a radius equal to 5. So that's the first part of the problem. Now it says to also find the area. Okay, so I'm going to change colors for a second. Okay, here's my formula for area. In order to find area, I need to have the radius, which I just solved for, and I need to have the angle, which I do have. So area equals 1/2 r squared times theta. I always like writing the formula down and then filling in underneath it. It's a good habit to get into. The r in this case is 5. I'm going to square it and get 25. My theta ends up being 0.4 because that's what they gave me up here. And on your calculator, if you say 0.5, which is 1/2, times 25 times 4, you're going to get, times 0.4, you're going to get 5 for your area. So this is 0.4 right here. So 1/2 times 25 times 0.4 gives me an area of 5. And that completes this video.